computer at a high level, starting with the program counter, the PC here, which is a combination of combinatorial logic and sequential logic, with combinatorial logic being how we calculate the next output of the PC, and then the sequential logic just basically being parallel flip-flops to hold the present state. So that output goes to a decoder that feeds into the instruction memory. We'll go into this in a little more detail in another video, but this basically just chooses what instruction we're going to be looking at for that given clock cycle based on the PC. So this instruction is used to set several control bits throughout the circuit. The first 2 bits of the instruction are actually used for the register file decoder. Again, we'll go into that in a little more detail. But the register file itself has several different clock inputs that correspond to the 4 registers that are in the register file. And so this is the logic that is used to generate those clock signals. We have a mux here that chooses between the SRAM output and the ALU output to figure out what we're going to store into the register file. And we see here we have the clock signals fed in. This also uses instruction 6, as that is the data path bit, I believe. Data select bit, excuse me. So that determines whether we use the SRAM or the ALU when we're writing to our register file. From there, we generate the outputs of the different registers, which basically tell us what's in all of the registers in the register file, which we then feed to these output muxes that use bits 4, 5, 2, and 3 of the instruction, which are basically our register select bits, so our register A and our register B, that we're going to use here on the output. You can see A and B. So this mux chooses which registers we're going to use for the calculations in the ALU, or actually which register we're going to use to store to SRAM. But so for the ALU, we have basically 3 components that make it up. We have the 2 register inputs that are used for the calculations, to the ripple carry adder, and the multiplier, which is all combinatorial logic. Basically, if something doesn't have a clock, it's combinatorial logic. But so these 2 outputs basically get fed into this mux, which chooses based on instruction 7, which tells us what kind of operation we have for the ALU, whether we want to use the add in or the mult in, or basically the results of the add of the multiply as the output of our ALU, which then gets fed into the register file. The last bit we have, or the last component we have, is the SRAM, which is basically just an array of SRAM cells that comprise 2 addresses in SRAM, each of 8 bits in length. So we have a lot of logic here that determines whether we're going to be writing to the SRAM, which address we're going to be writing to, if at all, and then which address we'd be reading from, if at all. And so those get fed into the SRAM here that basically trigger the access transistors. And then we have the input to the SRAM, which is from basically register select A. And then we get the SRAM out that gets fed into the ALU. So at a high level, I think that's all that's to be covered. Remember, anything with a clock signal feeding into it has some kind of sequential logic in it, which is basically the PC and the register file. And then everything else is combinatoric, although the PC has a combination of both. So yeah, that should be it.